السلام عليكم ورحمة الله وبركاته. الحمد لله والصلاة والسلام على رسول الله وعلى صحبه ومن والاه. Before I start, I'd like to express it's locked. I'd like to thank you all for coming here today. Special thanks to Boumediene for this initiative. And my presentation topic is about computational and AI methods in Fiqh and Hadith studies. In his influential book, Peter Novick presented a framework that we can use to categorize the different approaches of AI. So he presented 4 definitions of AI. The AI that we know today, most of the frameworks in the mainstream belong to the acting humanly. So his framework is based on 2 axes, the acting versus thinking axis and the humanly versus rationally axis. So in the thinking humanly axis, this is rooted in cognitive reasoning modeling. It models the thinking process using mathematical and logical tools. In the thinking rationally approach, it's regardless of human cognitive abilities. The task is to design machines that are based on logic, formal logic, and achieves rational thinking. And in the acting rationally, again, it's based on logic, but it is validated and evaluated based on the reward or utility maximization. Also, when it comes to modeling and representation of AI, there are 2 subcategories. There is the connectionists versus the computationalists. The father of computationalist is John McCarthy. He conceptualized the human brain thinking process as a symbolic operations on structured representation data. On the other side, connectionists, they look at the cognitive process as a biological process and try to imitate the biological process. So they conceptualize an interconnected set of devices and they encode the information by mutating the weights. And this leads us to the algorithms, learning algorithms. So algorithms in calculus are 2 foundational pillars in computational science. In the 9th century, Al-Khwarizmi, a Persian scientist, laid the ground for algorithmic thinking. It was until the 17th century, and amazingly enough, in the same year, Leibniz in Germany invented integral calculus, independently from Newton, who invented differential calculus. Soon after, a French mathematician known as Augustin Louis Cauchy, he merged the idea of algorithmic iterative thinking with differential calculus, and he invented gradient descent. And this algorithm is a standard today in many of the AI design frameworks, PyTorch, TensorFlow, with different variants. Yeah, with Augustin, of course, Augustin Louis Cauchy applied it to convex functions. What do I mean by convex functions? Convex functions are like well-behaved functions and smooth, where this algorithm, and also he derived convergence guarantees. However, real and modern objective functions and problems are highly non-convex and non-smooth. So we start to deal with stochastic gradient descent. So stochastic gradient descent is a learning algorithm, and it converges probabilistically, stochastically. So there could be some cases where there is divergence, so it doesn't learn. And also, especially when it comes to irregular problems, such as the one on the bottom right, the stochastic descent, gradient descent might converge to a suboptimum point, and it might miss the global optimum. What does it mean if it doesn't converge? That means your model is not learning, or is learning the wrong thing. And this might have impact on Islamic AI. Another limitation is the discrete versus continuous. Most machines are discrete. Of course, there are analogous machines, analog machines, but most machines are discrete, like the computer and the laptop. So these algorithms are digitized. So in fact, you're not applying the original gradient descent, you are applying an approximate version. And this adds to the stochasticity and probabilistic nature of LLMs. Connectionist approach, they train all these models using this algorithm. And also, by the nature of the objective of the designer, the objective is also biased, because I might have an objective that might not satisfy your needs. And also, the objectives are probabilistic as well. So we have a combination of probabilistic processes. Connectionists claim that the loss is a function of the number of parameters and inversely proportional to the data size and computational power. Another thing that challenges Islamic AI is that these models are data hungry and computationally intensive. So we might, and due to the sparsity of classical Arabic corpus, we don't have enough data for these models. Another thing is that it's computationally expensive, intensive, and we don't have the deep pockets of Americans to support and fund these high-performance computing. Number of parameters is a matter of choice. And also there is always a residual noise, which is epsilon, a small thing here, that is parasite. It doesn't suppress. It's a noise ball around the optimum. Now, having talked about AI, let's see where identify potential applications of AI in Islamic studies. Carmen, in his paper, he presented a motivational scenario where semantic hadith, a simple scenario, a user or a researcher might inquire about a certain topic in hadith or Quran. And this query is passed into concepts, and these concepts are used to retrieve relevant verses and hadiths, and also relevant scholarly opinions. Based on this framework or this scenario, I extended it to incorporate the different aspects of Islamic AI. So a very similar scenario can manifest when a user seeks for fatwa. In the first scenario, what we have, a user might inquire about a specific rule or fatwa. And then if a fatwa exists, we need some intelligence here. Then we can use LLM and leverage the RAG feature, retrieval augmented generation, to summarize this fatwa. And this is already available in GPT if you press this search engine button. I don't know if it's a premium feature or not. And this is assuming the fatwa exists and has been addressed in the database or scholarly websites. If it doesn't exist, then, by the way, this search engine is a secret soup. So every big brother like Google and other Yahoo, they have like their specific fine-tuned web crawler search engine. And so there are some ethical issues that may be flagged here. These search engines, and this is related to the previous talk, these search engines, they crawl websites. And in order for the crawling to be ethical, they need to check some files called robots.txt if they allow for crawling. If they don't allow for crawling, then scraping the websites is considered as a data breach. Second thing, some websites, they might allow crawling, but they may limit the number of requests. Imagine GPT, 1 million requests, bombarding a website with requests. And this is also a data breach, or a policy breach at least. So if we don't have a fatwa, then the request is passed into, we use ontology graphs. These ontology graphs can be manually implemented or learned using AI as well. These ontology graphs identifies entities and relationships, and it gets mapped into a set of themes and concepts. And once this is mapped into a set of concepts, we can retrieve scholarly opinions from Quran, Hadith, and Sunnah. Also, at each stage of this process, we need some intelligence. For instance, Quran knowledge graphs and Hadith knowledge graphs, as we will see, the people from University of Leeds, from Jeddah, they already built very robust and semantically validated Quran knowledge graphs and Hadith. And when it comes to Hadith authentication, we also need some intelligence. We don't have problem with Quran because Quran is preserved from any fabrication or any corruption, but Hadith is prone to corruption. Also, once the opinions are retrieved, we need some intelligence in order to summarize them. And also, if a conflict is detected, we may also need a set of rules to reconcile between opinions. So this is a summary of the first scenario. So web crawler searches for existing fatwa, summarizes. Although there is another method where when the fatwa is not available, for instance, Nazri, in his paper 2025, he fine-tuned al-LLM. Fine-tuning is considered as a risky approach because due to the probabilistic nature of LLMs, even after fine-tuning, it's still probabilistic. So there are no guarantees. Knowledge graphs, as I mentioned, are like logical key concepts. And they use usually predicate logic in order to link concepts to between concepts using logical relationships. Also, ontology management, it needs to be robust against temporal semantic drift because the Arabic that we use today is different than classical Arabic. And also, even classical Arabic can have a semantic drift depending on the context. Also, we need some strong disambiguation algorithms in order to, because classical Arabic has a high disambiguity rate compared to other languages. Ambiguity rate, sorry. It has ambiguity rate of about, there is an index, about 23 versus 2.3 in English, because English has been standardized. So we need strong and robust algorithms, both in ontology as well as in Hadith. AI can be used to build such knowledge graphs. And this has been achieved by Shimizu in English language. And Atwell, I think Atwell is here. Eric Atwell. Yeah, Eric Atwell has published a Arabic corpus as well as Quranic corpus that can be used for further AI training. When it comes to Hadith authentication, it's a laborious process. We can also leverage AI here and graph algorithms to authenticate chain of narrators. Hadith can be subdivided into two parts: the matan, the chain of narrators, and the statement of the prophet. So if you model the hadith as a graph, the nodes as narrators, and the edges are chains of transmissions, then we can simply do a lookup table process to rank the chains based on the rank of individual narrators and the reliability of the chains. And this was also achieved by Ahmed, Abdullah, and Ibrahim in his work, Isnad al-Hadith, Computational Authentication. Yeah. Also, when it comes to enriching the classical Arabic corpus, we can leverage AI for optical character recognition. And there are some projects by British Library and also by a French group called Kalfa that dedicate OCR platforms for Armenian and Arabic. And the last scenario is when there are no related verses or hadiths, neither hadiths nor verses or scholarly opinions. This leads us to ijtihad. Regardless of whether ijtihad can be achieved or not using AI, but a natural extension would be to use rule-based AI rather than LLMs. As a conclusion, we can say that the connectionist models are not the best when it comes to fatwa inference, but they can serve in data engineering and pre-processing. As a proposed way forward, we can use a hybrid neural rule-based symbolic AI and apply it to fatwa inference, especially when it comes to ijtihad. And this has to be done under human oversight because critical rulings in fatwa issuance must remain under the supervision of qualified Muslim scholars. This would balance computational efficiency with epistemic rigor in the domain of fiqh and hadith studies. And that's it for my talk. Thank you. Any questions?
Yeah, maybe one question while we're also changing.
Yeah.
Is there a question?